Hi, I'm Josh Nightingale, and I'm a PhD student at the University of Aveiro in Portugal. And today I'm talking about a project on the foraging of juvenile black-tailed Godwits and the role of social information and learning processes. So coming up in this talk, I'm going to quickly introduce you to black-tailed Godwits. I will then talk a bit about their social environment and social information. And I will finish by talking about how that can influence juvenile learning. Okay, so this is a black-tailed Godwit, an Icelandic one to be precise. And as the name suggests, this population breeds in Iceland. And then during the winter, they can winter anywhere from on the west coast of Europe, from Britain down to Iberia. And unlike the continental population, this population is actually doing quite well. So as well as the breeding range, the wintering range is expanding. And back in the 1970s, this map was produced showing all the key sites where at least 500 birds winter. But since then, this subspecies has been colonizing sites especially further north. So there's a lot of places where you can see them now, where you couldn't have done in the past. But as well as changing in space, these godwits are also changing in time. So during the spring, the date on which they lay their eggs has been moving earlier. And this is a trend that was linked to temperature. So in warmer years, they're laying eggs earlier, and the chicks also fledge earlier. So to sum up, Godwits undergoing range expansion and also an advancing breeding season. So what about social information, the social environment? Well, this is a set of processes by which individuals learn from each other. So as well as having their innate instincts, and as well as learning by experience, they can perhaps also learn by looking at each other and learning that way. So what does the social environment look like for a juvenile Godwit? After they leave the nest, Godwits in Iceland form these large flocks, and juvenile birds can join them. So at the beginning of the season, proportion of juveniles in these flocks is very low. And as more birds fledge and join the flocks, by the end of August, these flocks tend to be about 100% juveniles. Well, what does this mean? It means a juvenile bird joining a flock very early on would be surrounded by very experienced adults who know what they're doing, which is a good learning opportunity. Later in the season, juveniles might end up in a flock that consists entirely of other juveniles who might not be the best example. Okay, so the other aspect of this social environment is that juveniles also have to undertake a migration. They're all going to leave Iceland before the winter comes. But the latest ones might get left behind because all the adults have migrated already. And this may have consequences for where they end up spending the winter. So timing is really everything in this system. And some work I presented at Way to Study a couple of years ago showed that the earlier hatching chicks are more likely to recruit into the population, and the later chicks are more likely to be colonizing some of these new wintering sites in the north of the range. So to wrap this bit up, social environment strongly depends on timing. Later juveniles have less access to experienced adults, and they may therefore have less opportunity to learn. All right, so in this study, I really wanted to nail some of these things down. I wanted to confirm the seasonal trend in social environment and also look for any evidence of social learning, particularly juveniles learning from adults. So what did I do? Well, I went to Iceland, and this was my view for about 6 weeks. I drove around in my car looking for freshly cut hay fields, which is where these post-breeding flocks really like to gather. And when I found a flock, I would count the adults and juveniles in the flock to work out the age ratio. Then I would follow particular individuals to observe them foraging. I use that information to calculate an intake rate in terms of biomass over time. And also when I was looking at these individuals, I not only recorded their age, but also the age of their nearest neighbor. So whichever bird they were foraging next to, I recorded that as well. Okay, so what does the age ratio look like? Well, as expected, at the beginning of the period, didn't see many juveniles, and as the autumn progressed, the number of juveniles increased. So this is just showing the daily average of proportion of juveniles in flocks that I saw. And if we compare this with Thomas Gunnarson's work from 2005, the overall pattern is very similar, but perhaps a suggestion that the increase in the proportion of juveniles was a bit slower, suggesting that adults were maybe hanging around a bit later in 2021. But this daily average pattern also conceals a bit of variation. So in fact, throughout the season, there were flocks of 100% juveniles or 100% adults, and everything in between. Pretty much from the first day, it was only right by the end of August that I started to see consistently flocks that were mostly containing juveniles. What about evidence of learning? So I was wondering if there's a kind of a school for Godwits, where juvenile Godwits will look at an adult, see what they're doing, and try to copy them and learn how to forage this way. So I used the intake rate data, both for individuals and also taking a flock average. And I looked at any effect of proportion of juveniles or proportion of adults in the flock, the age of the nearest neighbor, the size of the flock, and also the age of the individual that I was watching forage. Okay, so what about proportion of juveniles? I'm about to show a bunch of graphs. All of them have this intake rate in terms of the amount of biomass over time. Don't worry too much about the units. And I'll always be showing adults in blue, juveniles in red, with the variable of interest on the x-axis. And I analyze all these data using GLMs. So what about the proportion of juveniles? It did not have any significant effect on the intake rate. So then I looked at the age of the nearest neighbor, and here we see intake rates of birds with an adult nearest neighbor on the left or a juvenile nearest neighbor on the right. And when I compared the effect of nearest neighbor, again, there was no significant effect. I looked at the size of flocks. This graph's on a log scale. And again, there was no significant effect. I also, so if we look here, you can see a lot of these birds have an intake rate of 0, because when I looked at them, they didn't eat anything. So in order to get around this 0 problem, I've also used averages for each age category within each flock to look at an average intake rate. And again, if we look at this with the proportion of juveniles in the flock, it's not significant. So overall, I didn't find any strong evidence for any of these variables influencing Godwit's intake rates. But one variable did come out as significant in all of these models, and that was the effect of age. So juveniles have a much lower average intake rate than adults. So to summarize these results, is there a seasonal pattern in social environments? Yes, there is, but with a lot of variation from flock to flock. I didn't find any strong evidence of any social learning processes in Godwits, other than to confirm that juveniles have a lot to learn. But if we look at this flock on the right, they potentially have a lot of opportunity to do it, because there's always flocks with a lot of adults in throughout most of the season. Okay, well, so what? Why does this matter? Well, I think juvenile foraging success has some important consequences for migration. These birds are about to have to leave Iceland and fly south to the rest of Europe. And as people in the UK have been finding out recently, when you have a long journey to make, it really helps to have enough fuel to do it. I also wonder if this low foraging rate could be an explanation for the low recruitment that we see, especially in later juveniles, because they have less time to find enough food. And it suggests to me that perhaps learning in Godwits is more a factor of experience from learning over time, rather than learning by observing each other. Another result that I'm quite interested in is it very much looks like this was a later breeding season in 2021 compared to 2005. So there was the coldest May for 100 years, but then during June and July, some areas of the country were reporting their hottest temperatures ever. So it was a really strange, crazy year to be doing this study. And it does seem like there's perhaps a lot more late birds. So a lot of adults hanging around later, and juveniles also staying around in Iceland long after I had left. And this might be because breeding was delayed, or because the warm later part of the season gave them more opportunities to re-nest. All right, so let's wrap this up. Did find strong variation in social environment during the post-fledging season, and juveniles have consistently low foraging success. I wasn't able to follow individuals in these flocks, so there is some turnover of juveniles. Some of the earlier ones might have already left, and by the end of the season, I could have been following younger individuals. I also wonder how much relevance this foraging data has for understanding migration, given that birds have a strong flocking instinct. Perhaps simply joining a group before you migrate is enough, and these kind of details of how they're foraging aren't measuring exactly what we need to know. So as the sun sets on my presentation, I would just like to thank my co-authors for helping collect and interpret some of this data. Solvik and Trin up in Iceland were great help and great company. And I'd also like to thank FCT for funding my PhD, and Interact and Profile Art, who gave me the money for going up north. And thank you too.